Hi everyone, welcome back. Good morning to all of you. And today we are going to focus about another important concept called electrochemical series, or we can call it as electromotive force series. In the previous class, we focused about concepts of electrochemistry and terminology involved in electrochemistry, as well construction of electro and electrolytic cells. And today's class is all about electromotive force. So before that, I just want to recollect what are the terminologies get involved in the electrochemistry. So basically, if you want to understand the concept of electrochemistry, you're supposed to be aware of the following terminologies called electrode, electrolytes, and electrode potential. So these three are the important terminology which get involved in the electrochemistry. So electrode, it will involve both anode and cathode, and electrolyte is nothing but molten salt solution, and electrode potential is nothing but whenever we used to dip a kind of metal rod in its corresponding own salt solution, it creates a potential difference. That difference is called as electrode potential. So basically, in order to understand the electrochemistry and electrode potential, we need one series called electromotive force series, or we can call it as electrochemical series. And this is going to be the electrochemical series where the elements are arranged in the increasing order of standard reduction potential value based on hydrogen scale, where hydrogen value is going to be 0. And the metal which are placed above hydrogen will have negative reduction potential value. Alright, the typical electrochemical series is given over here. Now the metals are arranged in the increasing order of standard reduction potential value based on hydrogen scale, where hydrogen occupies the middle of the electrochemical series. The reduction potential value of hydrogen is going to be 0, and the metal which are placed above hydrogen will have negative reduction potential value, and the metal which are placed below hydrogen will have positive reduction potential value. So based on the reactivity of the metals, the elements are arranged in the sequence. For an example, the lithium occupies top of the electrochemical series. Meanwhile, the fluorine has occupied in the bottom of the series. Now, based on the position, we can tell about the corrosion tendency and the reactivity of the metal in the particular reactions. Let us consider the metal which is placed at the top of the electrochemical series, lithium. Now, the value of the lithium is going to be minus 3.05. So this is a negative value. So therefore, based on the sign of this kind of electrochemical series value, we can predict the reactivity of the metal as well the oxidation behavior of the metals. So when you look at the reactivity of the lithium, this is highly reactive in nature because lithium can easily oxidize into lithium ion. So basically, when you look at the electrochemical series, here the reduction potential values of elements are arranged in the increasing order, or we can arrange in the reverse manner also, either increasing order or decreasing order. So when you arrange in the increasing order, lithium will occupy the top of the position. When you reverse it, now fluorine will occupy the top of the position. Now when you look at the reactivity of the lithium, it will have high oxidizing tendency, which means lithium will easily get oxidized into lithium ion. So Li will be converted to Li2 plus, Li plus, or in fact, it will release 1 electrons. So therefore, the oxidation tendency of the lithium is very high, as well the reducing power. Say for example, if the lithium is introduced in the solution compartment, it will supply electrons, it will act as an electron supplier. Now the released electrons will be consumed by the some other materials and that get reduced. So therefore, it will have the high reducing tendency also. Basically, the lithium will have oxidation tendency, but it is a kind of very good reducing agent. Similarly, if you take fluorine material, the value of the reduction potential value of fluorine is going to be 2.87. So very high positive value. Therefore, it will always have a reducing tendency, which means fluorine will try to undergo always reduction only. So therefore, fluorine will get 2 electrons from the electron supplier and get reduced to 2F minus. So therefore, it has high oxidizing power, which means when the fluorine is introduced in the any system, electrochemical system, it will try to capture the electrons and it will convert, or it will force the another material to undergo oxidation process to get electron from the concerned materials. So therefore, it will basically the tendency of fluorine is going to be reduction tendency. Whereas when the fluorine is introduced in the system, that will demand the electron from the some other compartment, and that will oxidize the material. So therefore, based on the position, likewise based on the position of the materials in the electrochemical series, we can tell about the reactivity and activity of the various metals. Now we are going to focus about the applications of electrochemical series for the engineering applications. Now applications. The first and foremost application of electrochemical series is going to be, it is highly useful to predict the corrosion tendency and the reactivity of the metals. The reactivity and corrosion tendency. Now what is by reactivity? So if the metals are placed above hydrogen in the electrochemical series, that metal will have high reactivity, which means they are ready to react with some other species and it get oxidized. And similarly, the corrosion tendency of the metal can also be predicted based on the position of metal in the electrochemical series. When you look at the electrochemical series, if the metals are placed above hydrogen, which means if the metals found to have negative reduction potential value, so those metal can easily undergo corrosion process. So basically, corrosion is nothing but simple oxidation process. Let us take iron as a representative example. If iron is exposed in the atmospheric conditions, now the iron will undergo oxidation process, simple oxidation, or we can call it as simple electron removal process. So therefore, we all know that the metal consists of metal ions, and the valence electrons are bound together to form one hard metal. Now we are going to replace the valence electron from the concerned metal. So as a result, what happens? The ion will be converted to iron 2 plus it releases 2 number of electrons. So therefore, corrosion is nothing but spontaneous disintegration of the metal, or we can call it as a simple oxidation process. Once it react with the atmosphere oxygen, it will produce Fe2 plus ion. Now the released Fe2 plus ion will react with the oxygen molecule which is available in the atmosphere, and it forms corresponding metal oxide. Depending upon the availability of oxygen, it may form either FeO2, or if more oxygen is available, it will convert it into Fe2O3. So this is nothing but rust formation. And the simple process is called as corrosion of the particular metal, or we can call it as rust forming process. And this kind of reactivity and corrosion tendency of all the elements can be predicted easily with the help of electrochemical series. In simple, we can define like this: if the metals are placed above hydrogen in the electrochemical series, all will have a high corrosion tendency. Similarly, if the metals are placed below hydrogen, they do not suffer corrosion, because those metal will have high reducing tendency. It will try to capture the electrons rather supplying electron process. So therefore, the metal which are placed below hydrogen don't undergo corrosion process. So that is the reason why the noble metals like gold and silver and platinum do not undergo corrosion process, because the pure form of metal is more stable rather than the corresponding oxide form. Basically, it used to form a kind of oxides like iron oxide and gold oxide type of oxides, but the lifetime of this oxide is very less. Lifetime is going to be very less one. As a result, once it forms the oxide layer, for example, we can take iron as a representative metal. When iron is exposed in the atmospheric conditions, it will try to form iron oxide, but due to the stability of the iron oxide, it will try to back to the original form, and it produce again iron material, gold material. Now we are going to take gold as a representative example. If gold is exposed in the atmospheric conditions, the gold will react with oxygen molecule and it forms gold oxide, but the stability of the gold oxide is very less. The stability as well, the lifetime of the material is going to be very less one. As a result, once it formed on the surface of the gold material, after the formation of due to the less stability of the gold oxide, it will try to form to the again original form. So gold oxide will be converted to again gold form. So therefore, simply we can say that if the metals are placed above hydrogen, they will all have high corrosion. They will all have. So therefore, the reactivity of the metal based on the position of the electrochemical, based on the reactivity of the metal can be predicted based on the position of metal in the electrochemical series. Similarly, the corrosion tendency of the metals can also be predicted based on the position. If the metals are placed above hydrogen in the scale, or we can say in the other words, if the metals are found to have negative reduction potential values, so those metal will have high reactivity as well high corrosion tendency. If the metals are placed below hydrogen, those metal will have very less reactivity in the atmosphere condition, as well the corrosion tendency is very less, because they do not undergo corrosion process, meanwhile try to capture the electron from the electron disk species. These two property can be predicted based on the electrochemical series, and these two are highly useful in the industrial sectors, because if we want to design any equipment or any component, we have to look at the corrosion tendency of the particular metal, because the corrosion tendency will play a very significant role, because when you go for automation process or any designing any material, the corrosion process, due to corrosion process, we are going to lose huge economic loss. So that is the reason why in European country, the corrosion process is always called as a $1 billion thief. Okay, so because every year huge economic losses occurs due to this corrosion process, so therefore European people used to call this process as a $1 billion thief. So if we want to avoid this corrosion process, as well as if we want to minimize the operation cost, we have to go for the metal which is having high positive value. So this is one of the indicator which tells about the corrosion tendency of the metal. So this is going to be the first application of electrochemical series. The second application of electrochemical series is going to be, it is used to predict the replacement tendency. Replacement tendency of metals. For example, in the electrochemistry is concerned, in the electrochemical series, during the construction of an electrochemical cell, let us take Daniel cell. Daniel cell is the best representative example for electrochemical cell. While we constructing the Daniel cell, we need to take two electrode and electrolytes, and these two electrode has to be connected through one salt bridge. This is one half cell, this is another half cell. This is going to be a zinc electrode, and this is going to be a copper electrode, copper rod, and this is copper sulfate solution, and this is going to be zinc sulfate solution, and this is connected through a potentiometer. This is going to be a salt bridge, and this setup is called as electrochemical cell. So the basic function of the cell is going to be, it used to convert, it's a device which convert the chemical energy into electrical energy, and the output of the cell can be measured with the help of the following equation. That is E cell is equal to electrode potential value of right hand side electrode and electrode potential value of left hand side electrode, and these potential value can be obtained from the electrochemical series. So here right hand side electrode is going to be copper electrode, this is right hand side electrode, this is left hand side electrode, and this is going to be an anode, this is cathode. The sign of anode is going to be -1, and the sign of cathode is going to be +1. And when you look at the reduction potential value of right hand side electrode, that is copper, it is a positive value, but it's 0.34, it is obtained from the electrochemical series, minus electrode potential value of left hand side electrode, that is going to be a zinc electrode. So this is going to be minus 0.76. So therefore 0.34 plus 0.76, the total output is going to be 1.1 volt. So therefore the cell output can be calculated with the help of this electrochemical series. For any cell, if we want to construct any kind of an electrochemical cell, we have to consider the electrochemical series, or we can call it as other words, the cell feasibility. The cell feasibility of any electrochemical cell can be predicted based on the electrochemical series values. For example, if the E cell value is positive, we can say that the cell reaction is going to be a spontaneous one, or else if the E cell value is negative, then we can claim that the cell reaction cannot be feasible, we won't get any kind of output from the concerned electrochemical cell. So therefore, okay, we'll come to the point. Now replacement tendency of the metal. So now how the metals are replaced. For an example, when you look at this electrochemical cell, now zinc will undergo oxidation process, which means zinc get oxidized, Zn will be converted to Zn2+. So at anode oxidation reaction will take place, and in cathode reduction process will take place. Now the copper ion which is available in the solution compartment, so Cu2+, which is from the copper sulfate solution, get reduced, and it will try to get the electron from the anodic area. Now get reduced to copper. So now copper metal from the solution is replaced because copper get reduced and it can be replaced from the solution easily. So therefore, if the metal, basically the electrochemical cell can be constructed using two dissimilar metals. Here one metal will have low value, negative reduction potential value. Another one metal will have positive reduction potential value, and if these two metals are connected together, it forms one complete electrochemical cell. Now the metal which is having negative reduction potential value will replace the metal which is having positive reduction potential value metals, and this tendency can be predicted based on the position of metal in the electrochemical series value. So if it is having negative value, that will replace the another metal from the corresponding salt solution. So this is going to be the second application of electrochemical series. And the next application is going to be replacement of hydrogen, or we can call it as hydrogen replacement tendency. How it can be calculated? So basically, in the electrochemical series, the negative reduction potential, some metals will have negative value and some metals found to have positive reduction potential value. For an example, now we are going to take two metal as a representative example. One is going to be zinc and another one is going to be copper. Now I am going to place zinc rod in the corresponding H plus solution. For example, zinc metal is placed in 0.1 molar hydrochloric acid solution. Similarly, I am going to place copper rod in 0.1 molar HCl solution. Now which one metal will replace hydrogen from the corresponding H plus solutions? So basically, when you look at the reduction potential value of zinc, it is going to be minus 0.76, and for copper it is going to be plus 0.34. Now we all know that based on, according to the reduction potential value, the metal which is having negative value must undergo oxidation process. As a result, zinc undergo oxidation and copper will undergo reduction process. So therefore, when you place the metal rod in the corresponding H plus solution, now zinc will undergo oxidation, zinc will be converted into Zn2 plus it releases 2 electrons. Now the released 2 electrons will try to react with 2H plus, which is available in the solution compartment, and it get reduced and it will be converted into corresponding hydrogen gas. So therefore, when you place the zinc rod, it will replace hydrogen from the H plus solution. Meanwhile, when you place copper in the zinc sulfate, when you place copper in the H plus solution, there won't be any reaction at all, because basically the nature of the copper is going to be reduction tendency. It will try to capture the electrons. The H plus already electron deficient species, so this is not enough. This is not sufficient. So hydrogen cannot supply hydrogen. Now we are going to look at the activity of copper in the H plus solution. Now copper cannot react with H plus because H plus is already electron deficient species. It can't able to supply electron to the copper material. So therefore, what happens? There won't be any reaction at all in the solution compartment. So therefore, copper cannot replace hydrogen from the H plus solution. However, the zinc can easily replace the H2 gas from the H plus solution. So this tendency can be calculated from the position of metal in the electrochemical series, or simply in other words, we can claim that if the metals are placed above hydrogen, it will try to replace hydrogen from the H plus solution, and the metal which are placed below hydrogen do not replace hydrogen from the H plus solution. So this is going to be the third application. And the fourth application of electrochemical series is going to be calculation of equilibrium constant. Say for example, in any reversible reactions, let us consider the following reversible reaction: Mn plus n number of electrons, it gives Mn. So when you take such kind of reversible reaction, the equilibrium constant is going to be, and it can be easily predicted based on the following equation. Let us consider the following redox reaction. Now the equilibrium constant for the redox reaction can be calculated by the following equation, that is E is equal to, that is electrode potential value of the particular metal is equal to 0.0591 into log of equilibrium constant. So based on the equations, easily we can able to calculate the fourth application of electrochemical series is going to be calculation of equilibrium constant K equilibrium. This is represented by equilibrium constant, K equilibrium constant of an equilibrium constant of chemical reaction. Now let us consider the following redox reaction Mn plus n electron, it gives M. So for this kind of reversible reaction, the corresponding equilibrium constant is going to be calculated based on the following electropotential value reactions. Electropotential reactions. E is equal to 2.303 into RT by NF in log of K equilibrium constant. So E is nothing but electropotential for the particular metal. So it can be simplified like this: 0.303, or it's nothing but gas constant. It's going to be 8.314 into T is nothing but temperature. Normally we used to conduct this kind of redox reaction in the room temperature, so it's going to be 298 Kelvin, and N is nothing but number of electron transferred in the particular reaction. So here N number of electron is transferred, and Faraday is nothing but 96,500 coulomb. 1 Farad is equal to 96,500 coulomb, and log of K equilibrium constant. And when you modify this equation, you can able to get the value for the equilibrium constant is equal to E is the value, that is reduction potential value of the particular metal into number of electron transferred into 96,500 coulomb divided by 2.303 into 8.314 into 298 Kelvin. So this is the relation which is used to calculate the equilibrium constant for any type of chemical reaction. And the last application of electrochemical series is going to be predicting the spontaneity of the chemical reaction. Spontaneity. Say for example, as we discussed earlier, when we construct an electrochemical cell, the E cell value must be positive 1. The E cell must be positive 1. So if the E cell value is positive, we can claim that the cell reaction is going to be a spontaneous one. In the other words, if the E cell value is negative 1, say for example, in the case of Daniel cell, Daniel cell, the E cell value is going to be 1.1 voltage, that the positive value. So we can claim that the cell reactions are spontaneous, which means zinc will undergo oxidation and it plays in the zinc sulfate solution. Similarly, copper rod will undergo reduction process. Copper sulfate will undergo reduction process. So it will be converted into copper. So this will happen spontaneously. Okay, when we couple both the electrodes through potentiometer. So therefore we can able to get the corresponding output is going to be 1.1 volt. In other words, which means if you reverse the electrodes, say for example, if copper is made as anode and the zinc is made as cathode, now what happens? The cell reaction is going to be reversible one. So we will get minus output, minus 1.1 volt. In such situation, the cell reaction cannot be feasible. So that itself indicates the feasibility of cell reaction. So therefore, if we want to construct an electrochemical cell, we have to place the anodes and cathodes in the appropriate position. Or in other words, according to IUPAC, if we want to construct an electrochemical cell, the lower value metal, say for example, if you are taking two metals like A and B, the A is having less value and B is having higher value. In this situation, the less value metal must be placed at the left hand side. The A metal must be placed in your left hand side and the B metal must be placed in the right hand side. So if you keep like this, we can able to get the positive value. In other words, if you keep reversibly, the higher value metal is placed in your left hand side and the lower value metal is placed your right hand side. Now what happens? The cell reaction will be reversed, which means we will get negative output. So the cell reaction cannot be feasible. There won't be any output at all. So this possibility or this features can be calculated based on the cell output value. So for the cell output, for the calculation of cell output, or we not to find out the output of the particular electrochemical cell, so we need to get the values from the EMM series. So these 5 are the important application of electrochemical series. Thank you very much for your fast listening.